Hello, everybody. It was nice to see some of you at the parade on Tuesday. Today, I want to talk about exponential functions versus linear functions. So something that's really good to be able to distinguish is the different types of functions that we've learned. So we've learned linear functions, and we know that linear functions are a line, and they look like a line. And exponential functions, we know they look like a certain graph, like an exponential graph. So they look like that, or they can look like that. Okay, so that's what exponential functions look like. This is what linear functions look like. So what I want to be able to do today is show you the difference, looking at numbers, the difference between an exponential function and a linear function. So exponential functions, to get from one y to the next, we multiply, and that's the multiplying factor. So we've multiplied by 2 or 1/3 or 10, whatever the multiplying factor is, that's what we're multiplying to get from one to the next. If it's a linear function, to get from one y to the next, we're adding the same number every time. So that's what we're going to do. We're going to look at some functions and decide if they are exponential or linear. And the way we're going to be able to tell is, are we multiplying to get from one number to the next, or are we adding to get from one number to the next? Okay, so let's take a look. So here we have A, and we have our x's, and they're going up by 1, so that's great. -1, 0, 1, 2, 3. And then let's look at our y's. We go from 4 to 7, 7 to 10, 10 to 13, and 13 to 16. So either we are adding the same amount every time, or we are multiplying the same amount every time. So the way sometimes I like to do it is just a little trial and error. So to get from 4 to 7, well, I add 3. Now let's see, does that work? To get from 7 to 10, do I add 3? Yes, I do. To get from 10 to 13, I add 3. And 13 to 16, I add 3. If I am adding every time, then it is linear. Okay, and they want an equation here. We know that linear equations, y equals mx plus b, where m is the slope, that's the 3, and the b is the y-intercept. That's the value when x is 0. So y equals 3x plus 7. Okay, let's take a look at B. 2 to 6 to 18 to 54 to 162. Okay, so if we want to say, well, maybe it's linear. Are we adding? So 2 plus 4 is 6, but is 6 plus 4 18? No. So it's not linear because we're not adding. So let's try multiplication. 2 times 3 is 6. Is 6 times 3 18? Yeah. 18 times 3, is that 54? Yeah. 54 times 3, that's 162. So it is exponential. And we know the form for exponential, a parenthesis b to the x, where a is the y-intercept. That's where I just highlighted. So a is 2. And b is the multiplying factor, so I'm multiplying by 3. Okay. Let's take a look at another one. So we have 32, 16, 8, 4, and 2. Okay, so we can look from 32 to 16. So let's see. If we were adding, what you'd have to do, if you weren't sure 32 plus what is 16, then we could work backwards and do 16 minus 32. 16 minus 32 is 16. So I am minusing 16. But is 16 minus 16 8? No. So it's not linear. I'm not adding the same amount every time. So then hopefully it's exponential. 32 times what is 16? Okay, if you remember this from the first few days we did this, if we're not sure 32 times what is 16, we can work backwards. 16 divided by 32 gives me a half. So 32 times a half is 16. is 16 times a half 8? Yeah, it sure is. Is 8 times 1/2 4? Yep. Is 4 times 1/2 2? Yes, it is. So this means it is exponential because I'm multiplying by the same thing every time. Y equals, we know the format for exponential, a parenthesis b to the x. A is my y-intercept, so that's going to be 8. B is going to be 1/2. That's my multiplying factor to the x. Okay, so let's try the next one. So we could try again with the adding. We did that same one over on C. 32 plus what is 16? If you remember from the one we just did, we said 32 plus a negative 16, or 32 minus 16 is 16. Okay. If I minus 16 again, 16 minus 16 is 0. 0 minus 16 is negative 16. And negative 16 minus 16 is negative 32. So I'm either adding a negative 16 every time, or I'm subtracting 16 every time. So this is linear if I'm adding the same amount every time. So y equals mx plus b. The m is the negative 16. And the b is the y-intercept. So actually it's just plus 0. It's totally fine to leave it like that. We don't usually need the plus 0, so I'm going to erase it. And that's it. Why don't you take a look at E and F, pause, and then come back, and I'm going to go over them. Pause, try it on your own, and come back. Okay, so I have 16 to 20, 20 to 25. I can tell right away it's not linear because 16 plus 4 is 20. 20 plus 4 is not 25. So it's not linear. It must be exponential. 16 times what is 20? Not sure. So let's, in our calculator, do 20 divided by 16. And I get 1.25 or 5/4. I'm going to just do the 1.25. It doesn't matter either way. Now let's try. In your calculator, do 20 times 1.25. Does that bring me to 25? It does. 25 times 1.25 does give me 31 1/4. So I know that this must be exponential because we are multiplying by the same amount every time. So y equals a parenthesis b to the x. A is 16. What is y when x is 0? And 1.25 to the x. And then in F, 180 plus what is 160? If you're not sure, you could do 160 minus 180. And we get negative 20 or minus 20. Okay, does that work? Is 160 minus 20 140? Yeah. Is 140 minus 20 120? Yeah. And if you're not sure, you can just have your calculator next to you and just try it out. 140 minus 20 is 120. 120 minus 20 is 100. So if I'm adding or subtracting the same amount every time, it's linear. So y equals mx plus b. So y equals negative 20x plus 180. Okay, nice. All right, let's look at a few more. So sometimes you might get asked a word problem talking about linear or exponential. Linear, we're adding or subtracting the same amount every time. So for linear, we're adding. And for exponential, remember, we're multiplying. And a lot of times you're going to see a percent because it's something's happening and it's increasing at a rate of 2%. That's how we would get that multiplying factor. So let's take a look at number 2. Which situation can be modeled by a linear function? Okay, the population of bacteria triples every day. That triples word, that's like something doubling or tripling, that's being multiplied. That is not linear. That would be exponential. The value of a cell phone depreciates. Remember that word? At a rate of 3.5% each year. I see a percent. I know that that is exponential, not linear. An amusement park allows 50 people to enter every 30 minutes. That's going to be linear. I'm adding 50, then I'm adding 50, then I'm adding 50, and adding 50 every 30 minutes. And 4 is also exponential. A baseball tournament eliminates half of the teams. So I'm multiplying by 1/2. That's going to be exponential. Okay. Number 3, which scenario represents exponential growth? So now I'm looking for something either being multiplied or I see a percent, which signifies that it's multiplication. A water tank is filled at a rate of 2 gallons per minute. That's actually linear. Every minute, 2 more gallons get put in. Plus 2, plus 2, plus 2. That's linear. A vine grows 6 inches every week. That's also linear. Plus 6, plus 6, plus 6. Every week it adds 6 inches. Number 3, a species of fly doubles its population every month during the summer. Doubling, tripling, that's multiplication. So that's going to be exponential. That's going to be our choice. Let's just look at number 4. A car increases its distance from a garage as it travels at a constant speed of 25 miles an hour. Every hour it's going 25 miles. 25 miles this hour, 25 miles the next hour, 25 miles the next hour. That's linear. Okay. Table below shows the value of 4 different functions for given values of x. So we have 4 tables. Notice what happens a lot is they'll give you different letters. So f of x, g of x, h of x, and k of x. And we want to know which is linear. So to decide which is linear, I need to look at the y's. Remember like when we did up top, we were looking at the y's and we were seeing which get added by a certain amount. So which one am I adding the same amount every time? So let's just try each choice. 12 plus what is 19? If you're not sure, do 19 minus 12, and that is 7. So then is 19 plus 7 26? Try it out on your calculator. Is 19 plus 7 26? It is. Is 26 plus 7 33? It is. So actually, we found our answer right away. But let's just take a look. Let's just make sure so we could see why the other ones aren't. -1 plus what is 1? It might be easier just to count if we think about our number line. -1, so the next number would be 0, then 1. So that would be adding 2. Is 1 plus 2 5? No, right? And 5 plus 2 is not 13, so that's not linear. How about 9 to 12? 9 plus what is 12? 3? Is 12 plus 3 17? No, so that's not right. And then what about -2 plus what is 4? 4 minus -2, if we want to work backwards, and we get 6. Or we could have just counted. -1, 0, 1, 2, 3, 4. That's 6 places away. Is 4 plus 6 14? No, 4 plus 6 is 10. So that is not linear as well. So first choice was the linear one. Okay. Function t of x is shown in the table below. Determine whether it is linear or exponential. So like I said, I always like to start just to see if it's linear. So to check if it's linear, 10 plus something gives me 7.5. If you're not sure 10 plus what is 7.5, work backwards. 7.5 minus 10, use your calculator, and it's -2.5. So 10 minus 2.5 is 7.5. Now here's the test. The test to see if it's linear is when I now do 7.5 minus 2.5, is that 5? Let's try it. It is. If I minus 2.5 from 7.5, I do get 5. Let's try the next one. 5 minus 2.5 is, in fact, 2.5. 2.5 minus 2.5 is 0. So I don't even need to check if it's exponential, because if it's linear, it can't be exponential. So determine whether it's linear or exponential. It is linear. And we can say the y values are, let's say, going down by 2.5 every time. Okay, very nice. Okay, there are 2 questions left, 6 and 7. I'd like you to try those 2 on your own and then submit all the questions to me. Okay, bye everybody.